National Electrical Code, specifically Table 300.5, addresses the requirements for bushings in metal raceways like Greenfield Conduit. The need for bushings hinges on conductor size and the potential for abrasion. If the conductors are larger than number 4 American wire gauge, or if the braid of the conductors is subject to excessive abrasion, bushings are typically required when using a metal raceway. The code aims to protect conductors from damage during installation and throughout the lifespan of the electrical system. When conductors pass through the end of a conduit, the edges of the conduit fitting can potentially chafe or damage the insulation. Bushings provide a smooth, rounded surface that prevents this abrasion. This is especially crucial for larger conductors, where insulation damage can lead to shorts, ground faults, or other electrical hazards. It is important to consider the grounding implications of using Greenfield Conduit. Greenfield, being a metallic raceway, can serve as an equipment grounding conductor under specific conditions. However, proper installation and termination are crucial to ensure effective grounding. The fittings used to connect the Greenfield to enclosures or equipment must be listed for grounding purposes and installed correctly. The NEC provides detailed requirements for equipment grounding conductors and bonding, and these requirements must be followed to maintain a safe and reliable electrical system. The absence of proper grounding can create a shock hazard and compromise the overall safety of the installation. The inspector's concern might stem from a perceived lack of protection for the conductors or a concern about the grounding path. Even if the conductors are smaller than number 4 American wire gauge, the inspector might still require bushings if they believe there is a risk of abrasion. The smoothness of the fitting's rounded edge is a factor, but the inspector might have a different interpretation of what constitutes a smoothly rounded edge. To ensure compliance, it's advisable to consult with the inspector and understand their specific concerns. You can also refer to the product listings for the Greenfield fittings you used. These listings often specify whether the fittings are suitable for use without bushings under certain conditions. Provide documentation or manufacturer specifications to support the installation. If there is disagreement with the inspector's interpretation, the next step is to appeal the decision through the appropriate channels. The NEC has a process for resolving disputes and obtaining interpretations of the code. It is important to gather all relevant information, including the product listings, the specific code sections in question, and any other supporting documentation, before initiating an appeal. Remember, electrical installations must comply with the applicable codes and standards to ensure safety and prevent hazards. Consulting with qualified electrical professionals and staying up to date with the latest code revisions is essential for ensuring compliance. Consider the following points to strengthen the argument for code compliance. Firstly, carefully examine the conductor insulation for any signs of existing damage or abrasion. Documenting the condition of the insulation can help demonstrate that the fittings are not causing any harm to the conductors. Secondly, provide detailed information about the Greenfield fittings used. Include the manufacturer's name, model number, and any relevant certifications or listings. If the fittings are specifically designed for use without bushings, provide documentation to support this claim. Thirdly, offer to install additional protection, such as sleeves or wraps, on the conductors where they enter the Greenfield fittings. This can provide an extra layer of protection against abrasion and address the inspector's concerns. Fourthly, request a written explanation from the inspector outlining the specific code sections they believe are being violated. This will help clarify the issue and provide a basis for further discussion and research. Fifthly, consult with other electrical professionals or code experts to obtain their opinions on the matter. Having multiple perspectives can help strengthen the argument and provide additional support for the installation. Sixthly, document all communications with the inspector, including the date, time, and a summary of the conversation. This will create a record of the interactions and help track the progress of the issue. Seventhly, if necessary, consider obtaining a formal interpretation of the code from the local electrical authority. This can provide a definitive answer to the question and resolve the dispute. Eighthly, if all other attempts to resolve the issue fail, consider filing an appeal with the appropriate regulatory agency. This is a formal process that allows for a review of the inspector's decision and a determination of whether the installation complies with the code. Ninthly, always prioritize safety and ensure that the electrical installation is performed in a manner that protects people and property. If there is any doubt about the safety of the installation, it is best to err on the side of caution and make the necessary corrections. Tenthly, maintain a professional and respectful attitude throughout the process. This will help build a positive relationship with the inspector and facilitate a resolution to the issue. In situations where the inspector's interpretation of the code is questionable, consider seeking clarification from the authority having jurisdiction. The authority having jurisdiction is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. This could be a local building department, a state electrical board, or another regulatory agency. Obtaining a formal interpretation from the authority having jurisdiction can provide a definitive answer to the question of whether bushings are required in the specific installation. The interpretation will be based on the specific requirements of the code and the local amendments that may be in effect. It is also important to ensure that the greenfield fittings are properly installed and taught according to the manufacturer's instructions. Loose or improperly installed fittings can create a poor grounding connection and increase the risk of electrical hazards. Use a calibrated torque wrench to tighten the fittings to the specified torque value. Inspect the fittings regularly to ensure that they remain tight and secure. The NEC provides detailed requirements for the installation and support of raceways, including Greenfield Conduit. These requirements are designed to ensure that the raceway is properly supported and protected from damage. Pay close attention to the spacing requirements for supports, the methods for securing the raceway to structures, and the requirements for protecting the raceway from physical damage. When installing Greenfield Conduit in damp or wet locations, use fittings that are listed for use in those environments. These fittings are designed to prevent water from entering the raceway and corroding the conductors. Seal the ends of the conduit with a suitable sealant to further protect the conductors from moisture. The NEC also addresses the use of flexible metal conduit, including Greenfield, as an equipment grounding conductor. The code specifies the conditions under which flexible metal conduit can be used for grounding and the limitations on its use. Be sure to comply with these requirements to ensure that the electrical system is properly grounded. When running conductors through Greenfield Conduit, use a suitable lubricant to reduce friction and prevent damage to the insulation. The lubricant should be compatible with the conductor insulation and the conduit material. Avoid using excessive force when pulling the conductors through the conduit, as this can damage the insulation. It is essential to conduct thorough testing and inspection of the electrical installation after it is complete. This includes testing the continuity of the grounding system, measuring the insulation resistance of the conductors, and verifying the proper operation of all electrical equipment. Address any deficiencies that are identified during the testing and inspection process to ensure that the installation is safe and reliable. When working with electrical systems, it is important to follow safe work practices and use appropriate personal protective equipment. This includes wearing safety glasses, gloves, and other protective gear as needed. To energize the circuit before working on it and use a voltage tester to verify that the circuit is dead. Never work on live electrical equipment unless it is absolutely necessary and you are qualified to do so. The NEC is constantly evolving to keep pace with new technologies and safety concerns. Stay up to date with the latest code revisions and interpretations to ensure that your electrical installations comply with the current requirements. Attend training courses and seminars to enhance your knowledge and skills. Consider joining professional organizations to network with other electrical professionals and stay informed about industry trends. Remember that electrical work is a serious business that requires knowledge, skill, and attention to detail. Always prioritize safety and follow the code to protect people and property from electrical hazards.